Hello guys, welcome to another video. If you see this question, they have given that a 10-meter thick clay layer is resting over a 3-meter sand layer and it is in submerged condition. Okay. Also, they have given that 2-meter thick sand with unit weight 20 kilonewton per meter square is placed above the clay layer to accelerate the rate of consolidation of the clay layer. Then they have given the coefficient of consolidation of clay and coefficient of volume of compressibility of clay. Okay. Now they have asked us to find out the settlement of the clay layers 10 years after the construction of the field. Right. So first we'll find out the change in effective stress due to the placement of sand. Change in effective stress due to the placement of sand will be equal to gamma into Z, which is nothing but gamma it is 20 kilonewton per meter square into Z2. That is 40 kilonewton per meter square. Now, the equation for volumetric compressibility will be equal to mv equal to delta h divided by delta sigma naught dash into h. Whereas delta h will be equal to mv h delta sigma naught dash. That is change in height due to the volumetric compressibility. Okay. So change in height or else settlement, initial settlement will be equal to 2.2 into 10 power minus 4 into 40 into h is 10 meter cube. Okay. 10 into 10 cube mm. Where we'll get the unit as meter, so we need to convert into mm for settlement. So we are adding with 10 cube mm. Okay. So we get delta h will be equal to 88 mm. And they have asked us to find out the settlement using Taylor's equation. Okay. Taylor's equation is given by dV is equal to CV T by D square or H square, anything. Okay. So we need to find out the consolidation at the middle of clay layer. Okay. This one they will not mention in question. For every question, you need to get understand. So CV is nothing but CV they have given us 9 into 10 power minus 2. CV it is 9 into 10 power minus 2. And the number of years they have given us 10 years by D, which is nothing but pi square, which gives 0.036. Also, the degree of consolidation we assume it as lesser than 60. So we get TV will be equal to pi by 4 u square. We need to find out the degree of consolidation, right? So from this equation, we can get u will be equal to 4 into TV by pi whole root. So root of 4 into TV 0.036 by pi, which gives you 0.214. So degree of consolidation U will be equal to delta H by delta H. Since U we have taken as integer, we don't need to calculate it to 100. We don't need to multiply it 100. Okay. So settlement after 10 years, that is delta H will be equal to U into delta H. Delta H will be equal to U 0.214 into capital delta H, which is nothing but 88 mm. Solving we get 18.832 mm. So delta H is nothing but the overall settlement. So settlement after 10 years with respect to 21.4% consolidation, we got 18.832 mm. In this question, they have given that the one-dimensional consolidation test is carried out on a standard 19 mm thick clay sample. 19 mm thick clay sample. So the odometer deflection gauge indicates a reading of 2.1 mm just before the removal of load. 2.1 mm just before the removal of load without allowing any swelling. So the void ratio at this stage means they have given the final void ratio and they're asking us to find out the initial void ratio. Okay. They have given the uh, initial thickness of the clay sample. That is H naught will be equal to 19 mm and delta H, there is nothing but the deflection gauge before removal of load, what it is showing, that is 2.1 mm. Also they have given the final void ratio, which is 0.62, and we need to find out the initial void ratio. So from the relation of height and void ratio, we know that delta H by H naught will be equal to delta E divided by 1 plus E naught. So delta H is nothing but 2.1 divided by 19 will be equal to delta E, which is 0.62 minus E naught divided by 1 plus E naught. So if you solve this, you get E naught will be equal to 0.82 is the initial void ratio. In this question, they have given a footing which is placed below 1.5 meter below the ground and it is transferring a pressure of 200 kilonewton per meter square. And they have also said that the clay stratum is normally consolidated. Clay stratum is normally consolidated. They have given the specific gravity of clay, compression index, and they told considering 2:1 method of load distribution, 2:1 method of load distribution, the primary consolidation settlement of the clay stratum is solution. The equation for primary consolidation settlement of the clay stratum is nothing but delta H equal to H naught Cc by 1 plus E naught log sigma, sorry, log sigma naught dash plus delta sigma dash or delta sigma naught dash divided by sigma naught dash. So delta H will be equal to H naught. H naught is nothing but depth of clay layer, which is 1.5 meter into Cc will be equal to, they have given the compression index as 0.3, divided by 1 plus E naught log, we don't know the value of sigma naught, also we don't know the value of delta sigma naught, so we'll keep like that, just like that is divided by sigma naught dash. So we need to calculate E naught, sigma naught and sigma naught dash. So to calculate E naught, we can calculate from the equation of gamma sat, saturated unit weight of clay. Gamma sat will be equal to G plus E divided by 1 plus E gamma W. So they have given the specific gravity of clay, that is 2.7. They have given the saturated unit weight of clay as 17. Also they have given the they have given the specific gravity of clay as 2.65. It's not 2.7, 2.65 plus E divided by 1 plus E. They have given the unit weight of water as 10. So if you solve this equation, you get E, there is nothing but E naught will be equal to 1.357. Okay. Now we need the effective stress. So effective stress we need to find out till the middle of the clay layer. For every consolidation problem, we used to find out the effective stress and change in effective stress till the middle of the clay layer. So if you see this question, the load distribution pattern will be like this. This is the load distribution pattern, and they are given the 2 vertical, 1 horizontal, 2 vertical, 1 horizontal. Okay. So this depth from the footing to middle of the clay layer will be nothing but 1 plus 1.5 by 2, that is 0.75. So 1 plus 0.75 will be nothing but 1.75 meter. Okay. That will be equal to 1.75 meter. And they have given the width of the footing B is nothing but 2 meters. So if you consider this as trapezium, now you will get this width of the footing is 2 meters. Okay, later we will solve with the formula. Now consider this region as XX, middle region as X. Okay. Now sigma naught dash at X is nothing but sigma dash of XX minus pore water pressure of XX. So total stress will be given by 1.5. Total stress will be given by 1 plus 1.5. is 0.5 plus 1.5, 2 gamma d plus 1.75 gamma sat, 2 gamma d plus 1.75 gamma sat. 2 gamma d is nothing but the 0.5 meter plus 1.5 meter into gamma d. So gamma sat is nothing but 0.5 plus 0.75, sorry, 1.25 gamma sat. 1.25 gamma sat minus pore water pressure. For silt and layer, there is no pore water, that is equal to 0. Plus pore water pressure of clay layer will be 1.25 into gamma W plus 1.25 gamma W. So which is nothing but 2 into gamma D will be equal to 15. Gamma D they have given us 15 and gamma side they have given us 18 plus 1.25 into 18 minus 1.25 into gamma W as 10. So by calculating we'll get this 39.25 kilonewton per meter square, which is sigma naught dash. So change in effective stress delta sigma naught dash will be equal to force by area. So there is a equation for this kind of problem, which is nothing but qb square divided by b plus 2 ng the whole square. This is the equation to find out the change in effective stress from the load dispersion pattern. Okay, so Q is nothing but 200 into P, 2 into 2 divided by P, that is 2 plus 2 into N is slope, that is 1 by 2 horizontal by vertical, and Z is nothing but 1.75 the whole square, which is 800 divided by 2 plus 1.75, 3.75 the whole square, where we get 56.88 kilonewton per meter square. UB square. Okay. Now you have to substitute all the parameters in the above equation, where you get delta H will be equal to H naught 1.5 into CC, it is nothing but 0.3 divided by 1 plus E naught. E naught is nothing but 1.375. 1 plus 1.375 into log of delta sigma naught dash. Sigma naught dash is nothing but 39.25 plus delta sigma naught dash, that is 56.88 divided by sigma naught dash 39.25. By solving this equation we get delta H, that is primary consolidation settlement, will be equal to 74.27 mm. In this question, if you consider this question as a diagram, you will get So this one is the clay layer, and it is under a pressure of 50 kilonewton per meter square. It is under a pressure of 50 kilonewton per meter square and is presently at equilibrium. So the clay layer is fully saturated. So under fully saturation condition, we can calculate the stress acting on the clay layer as effective stress. This is nothing but sigma dash will be equal to 50 kilonewton per meter square. And they're asking us to find out the effective stress and pore water pressure immediately on increasing the vertical stress. Vertical stress is nothing but the total stress. Okay, total stress, that is 150 kilonewton per meter square. So from this we can calculate that effective stress will be equal to total stress minus pore water pressure. So pore water pressure will be equal to total stress minus effective stress, which is nothing but pore water pressure will be equal to total stress 150 minus effective stress 50 will be equal to 100 kilonewton per meter square. So with the change in total stress, there will not be any change in the effective stress. So effective stress remains same. So with this, we can get the pore water pressure as 100 kilonewton per meter square and effective stress is 50 kilonewton per meter square. And they have given the effective stress. So 50 and 100, option A is the right answer. In this question, they have given a soil profile at present where the groundwater table is 5 meter below the ground level. And they also said that in the past, the groundwater table was below 10 meter the ground level. Groundwater table was 10 meters below the ground level. And now they have asked us to find out the over consolidation ratio. So we need to find out the over consolidation ratio at the middle of the clay layer, where we will be calculating the effective stress at the middle of the clay layer. Okay, solution. So over consolidation ratio, which is nothing but pre consolidation stress divided by present consolidation stress. Pre consolidation stress is nothing but sigma c dash divided by present is nothing but sigma naught dash. So pre consolidation says sigma c dash at xx will be equal to, that is total stress minus pore water pressure. Previously there is the water table is below 10 meters. So we need to calculate total stress of sand. This 17.5 into 10 plus total stress of sand below water table, that is 18.5 into 5 plus 17 into 4 minus of pore water pressure of sand 18.5 into, sorry, it's not 18.5, pore water pressure will be equal to 9.81 into 5 plus 9.81 into 4, 175 plus 18.5 minus 9.81 into 5 plus 17 minus 9.81 into 4, which gives sigma c dash will be equal to 247.21 kilonewton per meter square. So we need to calculate the present consolidation stress. Sigma naught dash. Present consolidation stress. The water table is 5 meter below the ground level. So it will be 17.5 into 5 plus 18.5 into 10 plus 17 into 4 minus 9.81 into 10 plus 9.81 into 4, which gives 175 by 2. 175 by 2 plus 18.5 minus 9.81 into 10 plus 17 minus 9.81 into 4. So from this we can get sigma naught dash will be equal to 203.16 kilonewton per meter square. Now the over consolidation ratio OCR will be given by sigma C dash, which is nothing but 247.21 divided by sigma naught dash will be equal to 203.16, where we can get 1.22. If you see this question, they have given that a clay layer of thickness H has a pre-consolidation pressure Pc and initial void ratio E naught. The initial effective overburden stress at the mid height of the layer is P naught. At the same location, the increment in effective stress due to applied external load is delta P. The compression and swelling index of the clay are Cc and Cs respectively. If P naught is lesser than Pc, which is lesser than P naught plus delta P, then the correct expression to estimate the consolidation settlement of the clay layer. So from this data we can get that pre-consolidation pressure, which is Pc, and the initial effective overburden pressure, that is P naught. So from P naught it is changing to Pc, and at initial consolidation clay will be in a swelling state. So we need to consider the swelling index, which in turn changes to compression index, because at initial, due to apply of water, clay will be in a swelling state, and due to the compaction, the clay will get compressed and water gets expelled out. So from swelling index it changes to compression index. So if you see the four options, if you see that P naught should change from Pc. Actually, previously it will be due to initial overburden pressure, and it should get added with consolidation, pre-consolidation pressure. So if you see the question, they have given that option C and option D, which is they have given PC and PC. If you see the option, it is from pre-consolidation pressure to pre-consolidation pressure, which is not the right option. And if you see option B and A, they have added from initial overburden pressure with pre-consolidation pressure. So option A and B can be the right answer. But if you see in option A, due to pre-consolidation at initial effective stress, they have given the index as Cc. So at initial effective overburden pressure, the index is Cs. Okay, at the final pre-consolidation pressure, the index is Cc. So at P naught, the compression index will be swelling index. So and at pre-consolidation pressure, the index will be compression index. Therefore, option B is the right answer.